our technical meetup organized by Motorola Solutions today. And maybe let's give a couple of minutes to let everyone join our meeting. And during this couple of minutes, I will describe our main topic for today. So today we would like to present two presentations regarding modern front-end development and why this topic is important, why it can be interesting to you. So nowadays we have a lot of very complex solutions being developed using different complicated front-end solutions, and that's why my front-end is getting bigger and bigger, and we would like to cover this topic today. So the first presentation will be presented by Bartek. So he's one of our architects in Command Central suite, working in Krakow, Motorola. He has more than 16 years experience of software development, and the last 6 years he is building web applications and cloud services. And he will cover the very hot topic. It's micro frontends in practice and how to use them, what are pros and cons of using this solution, and what difficulties can be faced during the development of micro frontends. The second one presentation will be presented by Scott. Scott is leading our design systems team at Motorola Solutions. This team is cross-functional group. It includes designers and developers whose role is to build out the infrastructure supporting front-end alignment across all our products, organizations, and platforms. So Scott will present a scale and collaboration presentation, which will be dedicated to our internal open source solutions and how to cooperate on them and how to implement new systems using open source in frontend. So one more organizational moment. So we cannot hear you, so that will be only the voice coming from us, from the presenters and myself. And I would like to ask you to register all the questions in our chat. And after the presentation, we will answer all the questions which appear in the chat. So please use this tool to communicate with us. And I would like to pass a word to Bartek to start presenting the first presentation. So Bartek, it's your time.
Right. So hello everyone, my name is Bartek Olejak, and today I would like to talk about our experience with adopting micro frontends. To give you a little bit context, I'm part of a team working on a Command Central suite, which consists of many products. Each of these products is used by different type of users, but there are some common things. First of all, we want to integrate all of these products together, and not only on the data layer, but also on a UI layer. So we would like to use the same components, UI components, across different applications. Then most of the backend services used in this product is hosted on Microsoft Azure Cloud. And finally, another common thing is that we are trying to write all UIs for this application in Angular framework. All right, so the question for today is how to scale up the development of the front-end applications and how to do that efficiently. So imagine that we have a development team responsible for one product, one application, front-end application, which is then deployed on a web server. In our case, we are using Azure CDN. It may be implemented, for example, in Angular framework. And at the beginning, this team is able to deliver new features really fast. However, over the time, after a couple of months, maybe years, the speed of the delivery slows down and significantly slows down. And this is because of this team has other tasks to do. For example, they spend more time on maintenance tasks like fixing bugs, reducing technical debts, supporting customers. But also internally, the application becomes more complex. So adding new features causes that they need to touch many places in such an application. So to fix this issue, management, company or business usually decided to increase staffing for such a project to make the project to work faster. And so we need to deal with a bigger number of developers. So usually we need to form new teams, split these developers into separate teams, which then they will be working on the same application. However, how to do that efficiently? One of the way is to modularize the application and assign responsibility for separate modules to separate teams. This model works has some disadvantages. First of all, these three teams still need to share a lot of things. Like they need to share the same technology, frameworks. They need to work on the same set of box end-to-end tests, and they need to maintain them. Finally, there is a big common part, which is usually called platform or utils, which need to be maintained. And also the deployment of this application is common. So one team cannot decide that they want now to deploy the application. They need to synchronize the decision with other teams. So because of that, we actually don't have three teams. We have one giant team which need to communicate together. So one of the solutions for this issue, which we use a lot at Motorola, is convert such one modules into library. So now we will have one team responsible for particular module or library, and this team, instead of producing a front-end application, it produces a npm package, which is then published to Azure Artifacts, our npm repository. Then this package is taken by consumer application teams, so they need to reference it in the package.json file and publish on their own server, web server. This model actually works quite well. It has only one main drawback. It's significant time needed to deliver changes. So this is time between the common component team introduce the change and until it is finally visible on a production system. And we observe that it may take even a couple of months for doing it, and it is caused by several factors. First of all, the small packages, which is shown on top of this page, is usually contains references to many external libraries. The most painful dependency is Angular version. So if the consumer team has, for example, application in Angular 11, however, the component right now is supported only in Angular 12, they need to upgrade the project to the newest version. Another reason why that process is so slow is that these consumer teams are not interested to take all changes, all versions which are produced by common component teams. They are looking on specific features, specific bug fixes. So because of that, we are losing continuous integration process. And doing integration from time to time, it's always a painful process and requires time for testing and making changes in the code. So here we have ideas how potentially we may solve this issue by implementing and using micro frontends in our applications. So definition of micro frontends is that these are techniques, strategies, and recipes for building a modern web application with multiple teams that can ship features independently. So returning to our initial example, now we have these three teams, and they are building something. So they are working on some part of the application. They are able to deliver it with their own cadence. Then we have this magic process with a question mark, which constructs the application which is then delivered to the customer. And the problem with micro frontend is that there is no clear answer how this magic process should look like. There are many tools, many frameworks, many solutions how this process may look like. And we could spend next 2 hours comparing, contrasting all of them. But instead of that, I will show you what we have selected and why. So we decided to use Angular elements, which are built into web components. And we decided to do that because of a couple of reasons. First of all, we already use Angular in most of our projects. So Angular elements, it is yet another library which can be used together with Angular, and it is maintained also by Google. The second reason is simplicity. It's really easy to learn Angular elements. There is no big difference between regular Angular components and the web components which are constructed through this process of build. So it's quite easy to learn this technology. The next reason is that we are building in this process web components. Web components, this is HTML standard implemented by all modern web browsers. And the beauty of the web components is that we can use such artifacts, such web component, and mix it with any other technology. So we can take the results of this build and include it in React.js, Vue.js, or even vanilla JavaScript project, and it will work, yeah? Because the web components should be self-contained, so it should contain all dependencies, should not require any other stuff from the hosting application. And finally, when we were thinking about selecting framework, we thought that Angular elements are mature enough. After working a couple of months with this technology, I will rather agree with this sentence. There were some issues, some challenges, but nothing which could prevent us from writing production-ready code. So let's have a look how it was working in our case. So we decided to extract as a micro frontend one of our component which was used for search. It was quite complex. It allows user to find the persons and vehicles. It was connecting to different backend services, which then were talking with customer databases. Also, the UI was quite complex because nature of the results which were presented. So for us, it was perfect choice for micro frontends. And now, then we have two teams, cat dev teams and records dev team, which are using the search components in the application. The team itself are producing web application, Angular web application, and they are publishing it on their own domain, like cat.commandcentral.com and records.commandcentral.com. And then when the user enter to cat.commandcentral.com in his web browser, firstly, the web browser downloads the Angular application content from the cat.commandcentral.com, for example, and then inside that code, so Angular application, there is a reference to search.commandcentral.com webpage from which the web browser downloads the search component. So as you can see, this construction, the application construction and composition of the search UI with the rest of application is done at runtime on a client side, so inside the web browser. And now the search development team can produce a new version of web component without asking CAD or records team about permission. They will just deliver a new version. It will be automatically taken by all users. Of course, they need to refresh the page or close and reopen the application. And during the startup, this new version of search component will be taken. All right, so how it will look like from the technical point of view. The micro frontend, as I said before, is published on separate URL. We have some convention for URLs at Motorola. It is usually one JavaScript file plus additionally CSS file. And from the hosting application perspective, we need to include a script tag with the reference to this JavaScript library. And then we can use that web component in the same way like native HTML elements. So as you can see, this web component has some attributes, is raising some events, it can have some inner content. So everything looks like native Angular element. And what's more, these are, as I said before, this hosting application can be implemented in any framework. So far was rather quite positive, I believe. So the question is, are there any challenges with micro frontends? And the answer is, of course, there are some. So the first, I think the most important part is to understand the contract between micro frontends and other hosting applications. The contract, first you can think about some interfaces which are provided by the web component. So names of attributes, list of events raised by these components, or data structure exchanged. But in practice, we found out that there is much more elements which you need to take into account. And so this, your micro frontends may require, for example, some initialization flow, so some steps to be done before the component is loaded to your page. The web component may require some external dependencies. I told you that it should be self-contained, but in practice we found out that in some cases it's good to pass some CSS styles from hosting application to micro frontend, or there might be some needs to include some external JavaScript libraries and use it in micro frontends, which are loaded by hosting application. Then these micro frontends may communicate with backend services. So it may require some additional scopes in user JWT token. And the hosting application needs to know about these scopes because it requests about them during the login process to authentication service. Then micro frontends may require some extra resources, like it may do some CPU intensive task, it may cache some data, so it needs more memory, or it opens a lot of network connections. And because everything is run under one web browser, we are sharing resources between hosting application and micro frontend. So such kind of information need to be specified in the contract. Runtime environment requirements are telling us about what kind of web browsers this micro frontend support, whether it supports mobile or not. And finally, UI composition requirements. So how much space is required for your component? What is minimum and maximum width and height? Whether the touch screen is supported and touch gestures, so such kind of things. So in the contract, we should always introduce changes which are backward compatible. To not force other application to change anything, we should introduce only additive changes. But in reality, it's impossible. You will always face a problem that you need to do changes in contract which breaks the existing application. And to avoid problem and give times for hosting application to upgrade, we have to include version in this URL. Yeah? So each time we are introducing such changes which are not backward compatible, we are increasing this number. However, you shouldn't avoid it. Yeah? If you are going to do a lot of breaking changes in a component, you are losing all benefits of using micro frontends because each change will cause that other application needs to adjust. All right, so the next important question is how to detect breaking changes early. Definitely, we don't want to detect them on production system. We need to change it as soon as possible. So there is no good answer on these questions. We created some techniques which may help us to catch such problems earlier. So first items, small, actually, this is quite small thing. We notice that when we are publishing and building a web component, we can also extract TypeScript definition files with all data structures and interface of these web components and publish them into Azure Artifacts. Then the developers from other teams can include this package as a dependencies and have the build time as well as runtime in the ADE notification that something is wrong or the interface is used wrongly. Another thing which we discovered is really important in case of micro frontends is investing well in the demo application. The web component itself you cannot test, you cannot run. It's just JavaScript file. So in order to test it, you need to have a demo application, and it's critical important to cover all use cases which are used by other application in your demo application. So it allows you to better test your code before promotion to testing environment, and also this demo application is used during end-to-end tests. We are usually publishing that demo application as a HTML with JavaScript files in the same way like the component. All right, so automated test. I don't need to emphasize how it is important in case of micro frontends, because we need to be 100% sure that after deploying the version, we won't break existing application. So we need to invest more than regular for such kind of testing. We're using Cypress for creating such tests, and of course, as I said before, these tests are using demo application to test the component. But it is part of it, partially true. Sorry. Also, other teams, so consumer teams, need to invest in testing of your components. They need to write tests, box test, and end-to-end test, which are focused on different area. And so they need to test interaction between applications and your components. And we also found out that this team need to do some kind of sanity checks whether the component was loaded, for example. And now you can imagine how many problems it may cause when, for example, component team publish new version of the component which has some changes on the UI, and it will automatically break the existing test for application teams. And there is no good solution for this problem, except for running these tests as frequently as we can to quickly spot the problems, and be prepared that sometimes your test as an application team will fail, not only because something is wrong in the component or your application, but because the component was changed and your test wasn't prepared for it. The next thing is communication between development teams. So we had some practices how to do that. Yeah. So one of the example is we are automatically generating notification about new versions of the component. We are including in such notifications list of pull requests which was made until last promotion. So other teams are notified and they can see what has changed, why, what kind of bugs were fixed, and so on. Another thing that we have to invest a lot in documentations, preparing wiki page, this demo application which I mentioned. These artifacts are needed to teach other teams how to use your components. And finally, this is the last item, but I believe the most important from all what I said before. The synchronization between teams is critical here. So the component team cannot work in isolated way from other teams. They need to track roadmaps of our teams, how the component is used, what kind of interaction they may expect to have between other application and their component, and vice versa. Also, these application teams need to be aware about roadmap of the component and be prepared for any upcoming changes, especially these breaking changes, which I mentioned before. So the question is, should I start using micro frontends in my project? And as always, in case of such question, there is no clear answer. But there are some factors which may point you that it's something for you. So first of all, if you have well-defined, isolated domain, like in our case, it was search component, which has a quite simple contract, and we can imagine that it will be quite stable. Yeah? So we don't need to introduce too frequently these breaking changes. Another reason why you would like to use a micro frontend is to have requirements to use your components in more than one application. And the last thing is when you have a requirements from, for example, from management that you need to accelerate. Of course, this acceleration needs some extra costs to be spent, but definitely micro frontends can help you with this. And one more thing I would like to highlight here. So without micro frontends, we had one frontend application. It might be constructed from separate modules, which comes from different repository libraries, doesn't matter. But from the deployment point of view, it was one deployable unit. And this unit were communicating with many backend services. By adding micro frontends, we are actually building distributed system. Now, these micro frontends need to communicate with their own backend services. They need to communicate with the main application, and sometimes even you can communicate between micro frontends inside one application. And you might think that you can move the same patterns, the same solution like you had on backend service, microservice to the frontend world, but it's not necessarily true, because in the front end part, everything is run in the web browser on the same machine in one tab, and you are sharing a lot of things between these components. You have one global scope. You have limited access to resources. You have some pool of resources. You don't have isolation between these components. Whereas on backend, we have, for example, Kubernetes, where you can deploy your containers, you have high availability, you can scale it up. So you have different techniques to guarantee stability of the solution. I'm not saying that micro frontends cannot be used with success. I'm saying that it's harder, and you need to be prepared for that extra cost. So from one hand, you need to pay more for more complex design architecture. Security will be also important aspect which you need to take into account. Testing, which I mentioned before, you need to be more careful with and automatize everything what is possible. You are also increasing operational complexity. And finally, the communication between teams, between components becomes to be much harder. But from the other hand, you are receiving simplification. So now the component team can be focused only on one particular domain. You have independence of publishing a new versions of your component. You don't need to wait until somebody else will let you know that you can publish new version. You have ownership of it. You can store your code of your component in the separate repository. And finally, you have freedom to choose your favorite technology, framework, or even definition of done can be different for your team. So I hope I was able to help you understand challenges with micro frontends, and now the decision whether adopt or not to adopt them in your project is in your hands. So thank you.
Thank you, Bartek. So we have two questions. The first one is, could you describe how data exchange between parent component and a page can be done? Is it bidirectional or?
Yes, so there are many techniques how it may be done. Sorry, I was not checking on them. One of them is through attributes. Yes, so components has HTML attributes, so you can pass data through the attributes. Also, you can use events to receive some notifications. So these are, if you are familiar with Angular framework, these are input and output parameters. And there is no big difference between regular Angular components and web components if you use it together with Angular. So this is the most appropriate way. Of course, you can use also inner content of HTML, as I had in my presentation. Oh, thank you. Oh, here I had. Yes, so HTML content, which may change also. Nothing prevents you from using global scope for exchanging things or generating some custom events, but it is not a good practice. You should rather use only the input and output parameters.
Okay, thank you. The next one question is, what about inner source approach? Is it better approach than this one to enable contribution safely? And here I have a question to Scott. Will you cover it during your presentation? Because I
I
think
will.
it's okay.
Yes,
Great.
I'll talk about that. But I mean, if there's a specific micro front end use case, you're welcome to address it, Bartek. But yes, I will definitely be talking about that.
All right, so maybe we'll leave that question after your presentation. It will be easier to answer.
Okay, good. So the next one will be about shared dependencies, for example, Cobalt components. So I think, Scott, it might be addressed to you as well. And would you like to cover it after your presentation, or?
Yeah, I mean the shared dependencies is an interesting. I'm not going to necessarily go directly into that, but a shared dependency, part of that is collaboration communication, right? Making sure that everyone is aware. Bartek, you talked about the stand-ups communication, how you socialize the information, and that's a big part of what our design system and our system language attempts to do, is to create that platform for the conversation and the shared information to ensure that that interdependency is both understood as well as documented to make it clearer to people what that path looks like.
Specifically about Cobalt and any other design system and the styles which are used in application, we found out that the hosting application, so this main application, may pass some styles to the inner web component. And it is a better way because it solves a couple of problems with integration of different frameworks and different styles in both things. Yeah, of course, web components has this shadow DOM, so you can control CSS styles to not flood the rest of application of the styles which are included in the web component, but there is also option to consume styles from the application by the microfrontends.
Okay, thank you, Bartek. So the next one question is, can you use Angular DI to provide something to the Angular Elements web component?
Yes, it's possible. So you can register it. There is a way for doing it. So you can have a service which is registered. So the provider is registered by the main application and use it in the micro frontend. There is a way for doing it. It shouldn't be done too often because it causes tightly coupling between application and component, but it's doable.
Okay, thank you. We still have a couple of minutes to answer the question, so maybe you could briefly describe how we can secure parent page from being destroyed by global variables events created by the micro frontend.
Yes, so there is a not good solution for it. Yes, so it's matter of doing it right code reviews, have some convention to and agreement to not use such techniques in your web components. So you shouldn't register anything in the global scope because there might be some conflict with the hosting applications. but there are no automatic tools for detecting such things. Yeah. So this is, I think, one of the things which you need to take into account. Yeah? So when I had this list of part of a contract, only the component interface put through these TypeScript definition files you can automatically detect. The rest of items needs to be manually detected during either writing the new feature in your component or during code reviews. So this is a hard topic, the hardest part of this micro frontends, to be honest.
Okay, thank you, Bartek. And the last question will be: can you tell something about using Angular router in Elements?
Yes, so you can register it also, but independent routers in Angular Elements, and we were using it also in our application. So if the paths are constructed correctly, we didn't had issues to use these both routers together. But it is quite technical things. I don't want to go maybe deeper here, but it's possible.
Okay, thank you very much, Bartek. Thanks everyone for asking questions, and I think that's the best time to move on to the second presentation, which is prepared for today. So, Scott, you are welcome, and that's your time.
All right, thank you very much. So I'm going to talk a little bit about scale and collaboration and how we've managed to scale our design system, which relates back to our micro front ends, in a global enterprise framework. I don't believe you should ever bury the lead. And so I think a quick hint about what I'll reveal in this presentation: there's no easy way to scale adoption. Companies of all sizes have difficulty with this process, and the path to adoption and growth needs care and attention throughout. What I will offer is some insight into the process we took at Motorola Solutions to find success in our implementation and launch of a design system. So the first question I'm sure a lot of you are asking is, who am I and why do you care? I've been with Motorola Solutions for over 9 years, and I've been a participant in driving the collaborative intersection of design and development for most of that time. Our design system team is cross-discipline for a reason. Neither design alone nor engineering alone can solve the complex front-end problems raised by a global enterprise company. We need a unified vision and a method through which that vision can scale, which is what our design system provides. If this sounds idyllic, it is. But creating an environment where a designer like me can speak to an attendance of engineers like yourselves is what our approach to systems at scale is really all about. And if you're neither a designer or a developer, you're still in the right place. We run our system like a product, meaning the entire company has a sight line to what we do. This means we need to collaborate with operations, product, marketing, brand, and everything in between. I describe the role that I and my team have as that of librarians. We're responsible for the care of the system, but we don't own it. And to overextend the metaphor, we also don't write all the books. We share that with the entire company. The system is really their system. It's the company's system and all of the developers and designers who work on it. For anyone who's not familiar with the design system, it's essentially a set of modular components that allows any product team to build aligned products rapidly using a shared library of consistently designed and coded elements. Google's material design is a very good example of a design system in the world. There are others. Most of the systems you'll find online will tell you how to build with their components and then how to extend that into your own apps. But they're not built on a shared or open source or inner source framework for the most part. Any that are tend to be small and a little more niche. At Motorola Solutions, we had a need for the scale of a system like material design, but with domain-specific requirements driven by the specialized use cases of public safety customers, and which could include inputs from all teams around the globe, since each group has the potential to uncover new needs and drive systemic change on a small or large scale. Design at Motorola Solutions is what we refer to as human-centered, meaning we think about the user as the driver for everything we build. If the user is a 911 operator, an in-field officer, or a citizen looking up crime statistics, we need to think of our system as a modular entity built to meet the needs of each one of those users. This is why an off-the-shelf system wouldn't meet our needs. Our difficulties live on both axes, complexity and scale. Adoption of a design system can range from slightly difficult to very difficult. But before we talk about scaling, I'd like to give a little bit of background about how we framed the system to enable us to meet our scale needs in the first place. We built a foundation that has led to our successful reach across organizations and global teams. Helping any organization adopt a new system, complete with new processes, can take time. When we started on this road, we knew we wanted to have buy-in from everyone involved, and the best way to do that was to ensure that everyone was literally involved in what we were doing. We looked at open source models, but too much of our work is tied to proprietary research, and exposing some of our domain-specific problem solving would expose trade secrets to our competitors in the market. What we realized is we wanted the open source ethos, but within our secure environment. We've been referring to this as open source internal, a way of seeing open source modeling within a closed environment. I was recently informed by a coworker that we're actually an inner source model. I wasn't aware of the term. I've done some research. It is very much the ethos we're operating on. So to the person who asked the question, yes, we're running an inner source model for exactly that reason. What all of this means is, while my team maintains the system, everyone in the company owns it. If you have an ownership stake in the outcome, you're more likely to participate in the creation of and care for that system. Open source code can become littered with bugs or a backlog no one maintains. And this is where my team comes in. For a quick overview, though, just to be sure we're all on the same page, part of understanding how a design system works at scale is understanding the difference between a design system and a simple set of visual guidelines. I've worked on visual guidelines in the past. They're essentially documents that cover icons, colors, line heights, margins that have to be followed and coded based upon some standards. Where the design system really helps us drive this at a larger scale is if you know you need to make a 24 pixel margin or your primary font has to be 16 point, it's really simple to instead pull a grid from a shared repo or reference a standard font style and then have those values automatically present. The difference between you need to make your primary font 16 pixels and simply referencing body 1 in live code to implement a 1 rem font size with corresponding 1.5 times line height is the difference between a risk of repeated small errors and the ability to push consistency at scale. The very act of making a design system is the first step to scaling your design resources and driving that consistency across multiple products at a global level. I think to understand how we manage what we have, it's crucial to understand the ways in which design systems, or any software repository, can be managed. Nathan Curtis, an excellent writer on systems and system governance, has outlined the 3 primary models at a high level, and the difference is simple. A solitary governance model that has one person or one team pushing all code. They maintain everything in the system, fix bugs, add features, and generally maintain the system for everyone else. There's an easy risk here, though. How do you weigh the priorities of 2 teams against each other? Size of sales, number of people waiting, number of end users. This governance system works best with smaller companies or singular product lines. A centralized governance model is a little more robust. In this case, a team or small collective helps to maintain the code and push it out from a point of shared understanding. The code moves one way, but as a centralized team, there's more exposure to the needs of the system users, so backlog grooming and bug triage becomes much clearer with a shared understanding. And lastly is a federated model. This gets more towards an inner source or open source model. It allows contributions from any user or team. It has the greatest sense of investment, but runs the risk of creating code with too many variants or someone, quote, fixing a behavior in a way that breaks it for someone else. So when we were weighing all of these different models, we had to figure out what version was going to work best for us. All 3 have pros and cons, but choosing one should be driven by your intent. Why does this system exist? As previously noted, for us, this goes back to providing consistency. So we consider the system an open source model due to the federated contributions, but we ensure a small, nimble, centralized team can help align check-ins, add code review consistency, and tie the UX needs of each product back together. This means we can put some simple rules in place. No component joins the library if there are not at least 2 applications using it. Now, this is generally easy to find. We have over 20 apps using our system, but it does mean strange one-off variants don't become the responsibility of the core system team to maintain in perpetuity. We can also put coding standards in place, and the small team at the core simply needs to check submissions as opposed to completely writing everything themselves. Now, obviously, we write some of our own code, but you can't scale a small, nimble team if you're trying to write everyone's code for them. It also means our centralized team can be multidisciplinary, designers and developers working together. Not only does this help us meet the needs of the company at large, it helps us be better partners as we build empathy for the functional needs of both disciplines. The partnership of design and development, and the empathy between them, is key to building a shared understanding. Front-end UI is the intersection of design and development, a space where these 2 groups of people work towards one common goal, making great products. A shared understanding between disciplines helps drive the scaling of our system, which of course brings us to the million-dollar question: how do you scale it? So I'll provide some details, but the simple answer is, for us, partnership. Bring everyone to the table. It's why we used an inner source model. It's why we made a hybrid centralized federated governance model. And it's why we built a framework of inclusive partnership between designers and developers, and between developers working on different projects. Bartek talked a lot about this when he was talking about the teams working on different micro front ends. This is very much the same space for us. We're collaborating with various development teams to ensure that the components, the behavior, and the user experience meets the needs of every product as we build it through a consistent lens. As with everything else, this, of course, sounds great, but it also sounds kind of ambiguous. So I'm going to walk you through some real-world examples to really try and bring some concrete clarity to what we're talking about. One misconception is that this idea that everything we get asked for has to be added. Otherwise, how can your system be seen as a solution for every team? On the surface, this seems like a necessary approach. But as I mentioned, the reason we have a system is to drive consistency. If we included every change from every team, we wouldn't be helping drive that consistency between products. Part of building consistency sometimes means saying no. While this may sound like a necessity of what we do, it's not always easy. Anytime we say no, it always comes with a reason. And every no is an opportunity to look for a solution we can implement. If we can't help the way someone originally asks us to, we try to find a different approach that will still yield success, both for us and for them. Always letting folks know why is a part of that solution. I thought the scenario would be best illustrated with a mini case study of sorts. About 2 weeks ago, I was engaged by a developer who wanted our autocomplete component to open automatically on focus. Their product had a specific need that meant on tab, the input field would trigger a dropdown as soon as it entered focus. Because we're centralized, we can discuss this from two perspectives: feasibility and desirability. Our component doesn't do this, but it could. The code can be discussed with our engineering team. The desirability can be raised with our small group of cross-product designers tasked to look across the apps for alignment. We can discuss if this is something we should do, and if so, do we make the element behave this new way every time? Do we make a variant? Is this something that should only exist within the code of that single application? The broad answer is, this is fairly custom and should live in a single application, as we wouldn't want the requested behavior in all of our products. But we did ask the developer to have the designer working on their product reach out to me or someone on my team so we could discuss this more completely. There is perhaps some behavioral alignment we're not seeing here. We never assume that we understand everything about every product because we're trying to look through this consistency lens. So a no is often only a no for now. And as I said, the real win here is ensuring that the developer requesting this understood why we said no. Our reasoning was that generally a dropdown appearing on focus would create a poor user experience. In some way that you've probably all seen, imagine tabbing through a form in Amazon, and imagine that every time you tab to a new field, a dropdown opened automatically on that keystroke. This would end up being frustrating. If you were trying to tab to the end of the form to change the country first so that you could do province instead of state, in my case, in Canada, you'd end up covering a lot of the fields as you navigated through. So your sense of place would be gone, and you'd have this frustrating, flickering set of dropdowns. So explaining the usability issue is a great way to share knowledge and ensure that everyone making decisions is basing them on the same conditions and intents. The why also allows the developer or a designer to start a discussion about the ways in which their app might need a change. And we can use that as a springboard to discuss component needs and modifications. We have a second responsibility, which is scale. There's another consideration in a company like this. Mortal Solutions is large. We have acquisitions and businesses at all stages of product development. We have more engineering teams than design support. Sometimes our developers need to make simple apps, engineering-facing dashboards, control lists, simple configuration tools, and they may not have design input. So making a system, one which they can draw from without needing designers for every decision, is an amazing way to provide value, but it also means any change that goes into the system may not have a clear design intent. So we try to monitor content to keep best practices in place so that anyone drawing components from the system knows that they'll work together as intended, at least in their basic forms. You can definitely make bad applications from good components, but components with too many configurations amplify those risks exponentially. So Motorola Solutions is not only a large company, it's a global company, and every site has specific needs we wanted to ensure we addressed. When we started working on the design system, we knew we wanted input from all over the company. To this end, we started by having some calls and meetings, but as this was before COVID and the world was locked down, we thought it'd be even better to go to these engineering sites and really get to know what the folks working in each location needed. It also gave us a chance to expose ourselves to the development culture in all these spaces. The development culture in Utah and Krakow are very different, and we wanted to have an understanding of what that difference meant and what it meant to us to work with those collaborative environments. So as I noted, we wanted to build an inclusive model. So we involved everyone we could reach in the creation of the system. Myself and a developer traveled to as many of the sites as possible when we were kicking the program off. We met with developers, designers, and product owners around the world. This meant the core of our system was driven by the shared needs of its users. If you want folks to use your system, you need to be delivering what they actually need. This was the information we wanted to gather from each one of these locations. That inclusivity, bringing people in and sharing the why, built the foundation of our approach. This meant the elements and rationale forming the basis of the system were being written and governed by the people who would use it. It also meant we could share with that audience as the system grew. Our next critical decision for adoption was to think of our system as a product. If this is a good product, people will want to use it. So we need to think about the users of our design system product. In this case, we actually have three groups of users. Designers. Does our system represent itself to the designers in a way that makes sense? Do they understand how the components are repeatable, consistent patterns and how they work together? Developers. Do our engineering partners understand how things go together? Are we using repo structures they can follow? Did we build using the right frameworks and languages? We did ask before we started, so we're using Angular as well. Do we maintain a transparent backlog of bugs? Do we make it easy for folks to contribute to our code themselves? Do we have clear standards? And our last group of users, certainly not least, is our end users, the customers, the people who are going to use the products we're building with these systems. Designers, developers, and customers all have to be accommodated by the structure of the system, and the applications produced by the core components have to meet those needs or they fall apart quickly. Our inclusive approach to the creation of the system and the structuring of our system like a product both helped us launch our MVP. We had involvement at the early stages and engagement built through the recognition of user needs. Scale, however, requires continued engagement. With any product, whether when you release to the world at large or a system like ours released to an internal user group, you need to continue the engagement in order to evolve with the changing needs of your users. Long-term health is maintained by keeping the channels of communication open. For us, that meant setting up a chat group. We started a Google group. We use Google. This could be Slack. It could be any other platform you use. But we set up a space to continue this collaboration. We use the space as a way to ensure everyone can be heard, from the basic questions like why is the UI blue, to the more complex questions around topics like accessibility, shared user needs, or the behavioral question of that tab focus discussion in the first place. It's meant we can invite everyone into our space to share in the discussion and the ownership. So the million-dollar question, did all of this actually work? Do we have engagement in our system, and is that engagement at scale? And the simple answer is yes. Obviously, we're not perfect. Obviously, there's still room for us to grow and improve and get more engagement with the company at large, but we have almost 50 components in our main library. The core library is built using Angular, as that's what our development partners requested when we met with them originally in those discussions. But as the company grew and as the use of the system grew, as we brought in more acquisitions, we had a group of developers looking to build a second library using React. We had some quick meetings, agreed to rewrite a few of our classes to be more framework agnostic, and helped review what they were building. They identified about 30 of our 50 components needed in their products and set about building those with their own development teams and no required coding from the design system team itself. This is a grassroots approach, really reflecting the impact of our inner source model. A team beyond our own included us as reviewers to help them build equivalent components in another framework, something that clearly would not have happened if we hadn't created an open source culture in our approach to coding. The adoption is both top-down mandated, but also bottom-up. We have teams reach out noting that they would like to use the system as they want to be part of our larger ecosystem of products, a clear sign that adoption is happening even without the mandate. The defects are also telling. At last check, our bugs were fixed at a rate of about 50-50. 50% fixed by the internal design system team and 50% by developers from elsewhere in the company. Those numbers change depending on how busy everyone is, and our goal would be to have the contribution from outside the company be greater than that from outside our design team be greater than that from inside. But it's a trend we're happy to see. The 50-50 split means people are invested at a very high level in what we're doing. And the engagement speaks to the larger ecosystem created around our work. The chat has seen a lot of developers help each other out. In a global community where work happens around the clock due to time zones, we try not to sleep much, but we do it occasionally. Having folks willing to help one another when we are offline helps me maintain the system and momentum. Now, as I said, this isn't easy. We always wish we could be doing more. We want to drive more change, help teams fix bugs faster, and answer questions more rapidly. Our goal, however, is to lean into our existing adoption and grow the shared support without growing our system team. We've scaled the system itself. Our goal now is to continue scaling our contributions. It's an ongoing process, but one I feel we've set ourselves up to achieve. So thank you very much. And obviously, feel free to reach out after this call, whether you're internal or external to the company. I'm more than happy to talk development, design, relationships with anyone. It's a passion of mine, and I'm happy to have a chat with anyone who's interested. Thank you.
Thank you very much, Scott. And I think the only one question is the same, so about inner source approach and how to make contribution safely. So if you have a couple of words to add on it.
So I referenced that briefly in the presentation, but the big part of that is creating a framework that allows for people to understand how to successfully contribute. So if you think about contribution, having clear dev docs, having clear specifications, having clear frameworks. We also use basic templates to allow people to build things into our system in a more meaningful fashion. So I think we've got this very clear sense of what it takes to contribute, and then we open it up. Those lines of communication, the chat, people being able to ask questions, we help review, we help people understand when there are defects that they can fix themselves, and we try to make it as transparent as possible so that everyone gets to have a stake in what we're building. If you think about an open source model, the community is what drives it out in the world. We try to make that community inside the company so we can drive the inner source model through the same logic.
Okay, thank you. Thank you very much for explaining this in more details. So actually, I think that's all questions for now. So that's the last chance to ask question. Let's give a minute. Okay, so I see in the chat we have only thanks and great presentations. So that's very good to see such comments. So I think we will be ending our presentations for today. So one more time, I would like to to remind you about our blog and all the details about our available positions in the company available on the Baldock job site. And besides it, following our webinar today, in the next weeks, there will be an article published regarding frontends, and also we would like to put links to our recorded presentations from today in this article. So please stay tuned, and we have a lot of interesting presentations for you as well in the future. So thanks everyone. Thank you, Bartek. Thank you, Scott, for great presentations, and see you later.
Thanks, everyone.
Bye.